Basically, yeah, first person here. Just been waiting for other other people to join.
Okay, good evening.
Only 10 people so far. That's why I was waiting. But I don't want to go beyond time. I don't want to waste our time. So we can start. And was anyone able to go through the exercise? Did anyone practice the exercise or try out anything? Okay, let's get started. Let me know when you can see. Can you see my screen?
Yes, we can.
Yes. Yes.
Right. Let's do a quick review of what we did in the last class. In the last class, we looked at grouping data, and we saw that if you want to group data with SQL, you can use the group by clause to do that. And an example is grouping by country, where you also count the number of movies that are from each country. So the SQL code that does that. And I also mentioned that if you should use group by without using any aggregate function, yeah, let's say you have, like now you have country and title, because you're not using any function on title, and the title column is also not in the group by because it's going to throw an error. Examples where you can group by multiple, not just grouping by one column. You can group by multiple fields, like in this case, we're grouping by language. And I mentioned you can use group by and order by together at the same time. Group by is going to group your data, while order by is going to sort your data. In this case, we're using ESC, so this is going to sort data in descending order. And we looked at some practice examples and some exercises. We also looked at filtering, and I mentioned if you want to filter the result of your grouped data, if you want to filter that result, and you have to use another clause known as the having. So you have to filter grouped data results. And I explained why the where clause doesn't work if you want to filter the result of a grouped query, and that's because of the order of execution. So in this example, we see that the line runs first before the where, and because the where clause runs before the group by, that's why you can't. How is it now?
Yeah, it's a lot better.
Okay. Because the where clause runs before the group by, that's why you can't use it for filtering. You need something like having, because having is going to run after the group by clause. And this just shows the order of things. And so today what we're going to look at is joining data. And this is the last thing we will be discussing because this is our final class. And started with joining data. So data joining is something that is very important when it comes to analysis because it allows you
Mr.
to, yes.
Good evening. Please, I just want to ask a quick question.
First question.
Okay, can we visualize data with Postgre? Because I saw it there, down there,
Yes,
like make chart.
PG admin has a tool for that allows you to visualize data, but it's not something you'll be using. What you'll be using is either maybe Tableau, Power BI, or Google Looker, one of those tools. But if you want to quickly visualize your results, you can use that tab that you saw.
Okay,
So
thank you.
hope that answers. Okay, you're welcome. Right, so data joining. Data joining is something that is very important when you're carrying out analysis because it allows you to get a more robust data and you can perform a wider range of analysis because you have more data. Think of it this way. Let's use this example. We've been working with the films database. So let's say we want to analyze things like Netflix, like number of people that like the movies and the rating of the movies, maybe the number of dislikes. You find out that the current data we have, we don't have that information. And what you have to do in most cases will be to go online, find another data set that has that detail you're looking for, and then you download it, which now means you now have to join that data set you have with this other one that is present. You join the two data sets together so you can analyze the data and get a more comprehensive analysis. So that's where data joining comes in. So it's an important skill to have. It's not just SQL, analyzing maybe in R or Python. You may have the need to join your data together. In SQL, we have different kinds of joins. We have inner join, left join, right join, outer join. Then there's one other kind of join, which is cross join, although it's not something you may use often. That's why I'm not bothering with that. Even this four that I've mentioned, the most popular kind of join are inner join and left join. Those are the two joins you'll be seeing most of the time. So we're going to go over all the joins, all the kinds of joins. But before we do that, let me talk about some concepts in a database. That's the concept of a primary key and foreign key. So a primary key is a unique identifier for a table. If you have a table, there is usually a column that contains a value that allows you to uniquely identify each of the record in that table. Let's say you're going to the market and you're making a list, you want to shop. In your list, you start with number one, okay, I want to buy rice. Number two, I want to buy beans. That's your market list. And the numbers you are using there, the numbers you're writing, number one, number two, number three. In this instance, that'll be your primary key because it's what you're using to identify each of the record. So if I ask what's the second item on your list, your brain automatically goes to number two and you check what's there, number two, that's beans. So that's a primary key. In the context of a database, in your table, you usually have a row like that's one of the requirements for your tables in a database primary key. This is the primary key or ID. This is the table about orders. Maybe when your customer made a particular order from a website, you just have a table that stores that information. And now you create a primary key to show each unique order. So you know that order one is this is the record for order one. This is the record for order two, record for order three. So that's what a primary key is. Now let's look at the foreign key. The foreign key is a primary key in another table. So it's basically a primary key of another table. In this example, this table we're looking at is the and we have this value ID. Our customer ID is a primary key that belongs to another table. And can you guess what that table is?
Your earpiece or your this thing is not really helping. At least for me, I don't know about others, but
Yeah, it's true. It's actually cracking.
Okay, how is it now?
Better.
All right, thank you for letting me know. Okay.
Can you go over it again? Yes.
Yeah. I was saying in this instance, this is the primary key of this table. We are working with the orders table, and this order ID is now the primary key of this table because it allows us to see each unique order. And I mentioned a foreign key is a primary key of another table. It's a primary key of another table, so you can think of it like an ambassador that's representing its own table in another table. And a perfect example is the customer ID. The customer ID is a primary key in another table, and that table is the customer table. The customer table is where you have information about your customers, their name, address, phone number, all those stuff. And on that table, you have a customer ID that allows you to uniquely represent each of the customers. So now it's here in this table, so you can find out the customer that actually bought something. Think
Mr.
of it.
Ini, it's still cracking.
Then I don't think it's here. It's probably, I don't know why. Maybe network. I want to check. And it's not network. I'm not sure why. Yeah, why it's cracking. Well,
Would you mind to ask him again, because I could barely hear you. It's cracking so bad. Please, let's see if it
Yes,
will be
Mr.
better.
This time he said this. You have to log out and log in again.
That's serious. All right, let me log out.
On the players, I think, should always be made aware of that as quickly as possible from the sidelines. Reduce the possibility of something of a
Hi. How is it now? Still cracking?
No, for now. I'm cracking.
Okay. Let me share my screen. Okay, I was talking about the concept of foreign key. Now my voice isn't cracking in your end. And I mentioned the customer ID, how the customer ID is a foreign key because it is a primary key, or it is the primary key of another table. And now that table is the customer table, the customer's table. So think of it this way. Let's say we have in the university, they usually give students something known as the reg number, registration number. And now you know that your registration number is unique. So only only a student can have that reg number. You can't have two students with the same reg number. So that reg number automatically becomes a primary key if they're working on the student table. The university will not have to care. They don't care about your name, your age, all those details. All they need is your reg number. And once they have your reg number, they can find out everything about you. They can find out your name, your email, apartment, those stuff. So think of customer ID. We don't need all information of a customer. We just need their ID. And once we have their ID, we can now use that ID to get their details. In this case, the first order was made on January 15th of January 2020 by customer 101. What we need to do is go and find who customer 101 is in the customer table, and then we'll be able to now get the details, the name of that customer. So this is the foreign key. Think of the foreign key as an ambassador that represents another table in the table. So this is your primary key. It's the unique identifier. It's what you can use to identify unique order. Then your foreign key, example, customer ID. Okay, starting with the first kind of join, inner join. So the inner join is going to allow you to include record in which the key is in both table. We will look at a clear example so you understand this. This is the syntax of inner join, how you're going to use inner join. So you select all the columns from the first. In this case, you want to join two tables together, Prime Minister table and President table. But you want to join them using inner join. So this is the syntax, and you're joining them based on. For you to join two tables together, there must be something that the two tables have in common. There must be something that the two tables have in common. If not, you won't be able to join them together. And it's not any kind of table you can join together. There must be a relationship between the tables you want to join. We'll go more into detail of that, but I just want you to see what the syntax looks like. So you have inner join. Okay, quick note here is you should use join. Let's say you don't add this, you just use join. Then by default, SQL is going to perform inner join. So by default, if you don't specify the inner, you just use join, maybe from Prime Minister, President, then SQL is going to use inner join. So inner join is the default. All right, so let's understand how inner join works with this example. So we have two tables. We have the order table and customers table. Let's say we want to merge these two tables together, and we are using inner join. What do you think the merge table looks like? Remember, inner join is just going to take the two where they have things in common. Okay, let me go over this. So on the table, we have order ID, we have dates, and we have customer ID. On this side, customers table, we have the customer ID, the customer name, customer email, customer's phone number. If we want to join these two tables together, what do they have in common that we can use to link them? Have you noted anything that they have in common?
Customer ID.
ID.
Exactly, the customer ID. In this case, customer ID is the foreign key and the primary key because this is the table where it belongs to customer ID. Now, it's like a representative. If you want to get more detail about the customer, you can just link it back to the customer table and it will show you more information about this particular customer. So in inner join, you're going to be not customer ID because that's what this table. So inner join is going to show you the records, the customer ID matches customer ID here. So where the customer IDs are common, it's only going to give you those records where the customer IDs are present in tables. Let me use that. If the customer ID is present in both the orders table and in the customer table, and those are the records it's going to give you. In this case, we have customer 101, 101, 102, 102, 103. Now we have 100, but there's no 104 yet. We have 105, but there's no 105 here. We have 1 here. We have 107, but there's no 107 here. So in this example, I'm using a very small data set, so it's easy for you to see how it works. We only have 3 customer IDs that are present in the 2 tables. So inner join is just going to give you those 3 IDs. So this is going to be the result of your inner join. In the inner join, you're only going to have 101, 102, and 103 because these are the customer IDs that are present in the 2 tables. So every other thing that isn't like present, that is in common to both tables, it's going to ignore them when you're doing the inner join. So that's how the inner join works. And let's think of a practical question here.
Mr.
So
Ini, please, the question.
Yes.
Okay,
Now, what's
the
your
customer ID, yes, the customer ID, I can see that 3 are the same, but the customer name and customer email, are they the same on the 2 tables?
Let's see. So this is John Doe Donut example. Yeah, they are the same. It's just the record. So it's getting the record from the other table and the customer's table, and it's putting them together in one table. So yes, the order did be the same.
Okay.
Yeah. So John Michael Johnson it be the same. A practical example. So there was a project I worked on some years ago. It was in the healthcare industry where I was trying to predict the lifespan of cancer patients. So I had 2 different data sets. The first one was on the patient's medical record. So things like the patient's name, patient's blood group, all the stuff. And the other data was the patient genome data. So there's something known as gene expression matrix. There are over 60,000 columns in the data. And I wanted to get a data set I could use to train machine learning model, so an AI model to predict how long the cancer patient has to live. And to do this, I had to join the two tables together based on the patient ID. So the patient ID that is present in the medical record and the patient ID present in the genome data. So that way, for each patient, I get both their medical record and their gene expression matrix data on the same table. Now, of course, there are some patients in the medical record data that isn't available in the gene expression data. So in that case, I don't want to have any missing value. Like if I'm joining the two data together, I don't want to have any missing value. So in that case, I used an inner join. So it will just give me all the records of patients that are common to tables. So I know I'm working with a complete data. I can now build an AI model, train an AI model, not the one where the patient ID is there, but the patient's gene expression data is not available now. That's problem. Imagine to deal with 65,000 missing data. So they don't want that. So that's a practical example of how or where you may use an inner join. If you just want your output to use the records where the records that exist on both tables, then you use an inner join. So any questions so far on inner join?
Yes, excuse me, Mr. Ina. Please, can you go back to the tables so that I will be able to ask my questions? Okay,
Right.
thank you. You know, the other table, there is no name there. There is no customer name or customer email. What in a situation, the two tables have different customer name and different customer email and the same cost ID? Pardon?
This table should have customer name, customer email.
Yes, that is different from this customer name and customer email. How are we going to join them together?
Okay, so if any scenario like that should ever occur, then you know that that's a bad database design because the data there isn't consistent. It's not consistent. So if that should ever happen, know that it's the database design is bad or in database, they didn't do a good job because that shouldn't be the case. There's no way in a real life situation you should have a customer maybe on one table. You have this ID representing a customer saying this customer is John Doe. And you have the customer.
Hello.
Yes.
Okay. As a result of some of the other readings that one has done, I guess you are now speaking now to the relational quality of SQL here as a relational database management system. I want to believe, and also, I also want to believe that the beautiful question that the lady just asked now is also speaking to the acid characteristic of a structured database like SQL. That is atomicity, consistency, integrity. I'm just picking my brain, listening to you now. Some things seem to be falling in place. That's just that's okay.
Exactly. So exactly what you said. There are some rules like when you're working with SQL has some rules. The relational database, so it doesn't allow some things to happen. Doesn't allow some things to happen like data inconsistency. You see, you shouldn't have a case if I know people can make mistake, and then if that same customer on another table, you have that kind of information, but it shouldn't be so. The way a database is arranged, a relational database, let me be specific. If you're putting things into tables, we call that normalization. I don't want to go too deep into database theory, but they call that normalization because you are separating the details of the data, you're breaking it into separate tables. And in this case now, you've broken one into orders tables, so it's a table that only shows the order of the customer. Then you have another table that shows the customer details exactly. So you won't have that what would I call it, that situation where on this orders table you now have another customer name, customer email. That
I
database
think,
design is wrong.
Ini,
Yes.
I think my suggestion, I was going to suggest it to David. I think my suggestion is that the next class is better that you people start with us from creation of tables, because let's be very honest with ourselves now. Some of these things, some of these characteristics that we are now using to dig in this explanation are relative to the lady's very beautiful question. If we had done how to create tables in the first place, we would have known that there are some basic rules to follow that will not make some of our concerns or anxieties happen.
Okay.
Thank you.
All right. That's a good point. I'll take note of it. Creating tables. I did think of it when I was designing the syllabus. It's just the creation of table. Like we have 3 weeks to cover the request for data analysis, and the time is short. So that's why I didn't include it. I just made, the plan was to make extra videos, like additional content that people can look and learn, and okay, this is how you of that. And then for the class, we focus on Postgres for data analysis. But thank you for your suggestions. None of it. Well, your question is a good question. But for now, just know that that kind of situation is likely to occur, where you have a different email here and you have, it's not likely to occur. Any other question? Before we move on to the other kind of.
Ini,
Yes.
please, I don't know, your volume or your speaker, it's really, really bad. It's cracking. And it's making it difficult. Like the previous video, if you had to play it over again, you don't find it comfortable to hear it while it's skipping. It's a bit annoying. I don't know if other people find it offensive or annoying. You don't enjoy listening to the videos. And same thing is happening now. You've been cracking since we started the class, trying to adjust your speaker, and it's still repeating. Some of the words we are struggling to understand, putting one on two together. The thing is really, really not flowing very well. I don't know if others are not, if it's okay with others, but for me, I don't really enjoy it.
In addition to the genuine observation of the lady, I don't know, I guess it's your device, but in addition to that, may I use this opportunity to implore you that if there is a way you can increase the volume when of the recording before you publish it for us to download, because like she rightly stated, sometimes listening to, I've been following some very good points you are making in those recordings, but I've been straining my ears. I thought it's because I was getting old. I never knew it's not.
No, you're not getting old. It's general.
Okay.
I think Mr. Ini, you have to remove your earpiece and speak without earpiece.
I'm not
Let's know
using
if it's
earpiece.
better.
I'm not using earpiece.
Okay, in addition to the concerns raised, please, I have a question. You didn't really show us how you are able to arrive at your results, the joint results. You know, you showed us this table and the next thing we saw was the result. So how are we going to combine it, the command to use?
We're going to get to the commands part. I just want you to know how it works.
Okay.
For the speaker part, I don't know. Did you have this issue from day one, like the very first class and the second class? I mean, besides
No,
the
not
last
at
class.
all. No, I think it's just the last two classes that had that kind of
Last 2
issue.
classes. Yeah.
Yes, it's the bridging is just too, so I just had to like skip. I'm finding it like skipping. It scratches the ears that you're uncomfortable to hear that.
Okay. Okay. I'm not even sure what's causing this.
Sorry about that. Sorry.
Yes.
The level though, for me, you know, even in the sessions or the recordings that were clear, it's like you don't like noise. You are a very nerdy person. You don't. So it's a bit. I will be straining my ear. I was almost going to give the recordings to, because I have a production studio that I'm involved in. I was going to give it to an editor to raise the volume for me, so that I can hear you sharply. I don't know, but you may not be able to help that. Maybe it's the setting of your computer.
I'm not even sure.
Thank you. It's okay. Just continue with the class. Let's not stress it.
Let's continue.
All right. Right, so I'm moving into left join. This is the command that will do the left join. We're going to get to this part later. I just want you to understand how left join works. So left join is going to retrieve all the rows from the left table. Left join is going to get all the rows from the left table, and then it's going to get the matching rows from the right table. We're going to look at an example, but the syntax for it is left join. So the first table, this table here in the front statement, this is the left table, and this other table here is the right table. So we are joining two different tables, the left table and the right table. And let's understand how it works before we get to the answer. So we have the order table and the customers table. In the left join, the records here, they're going to get in that. So think of it, in left join, your table of priority is the left table. In this case, this is the left table, the order table, which means everything here is to get intact. All these IDs, you're going to have ID 101, 102, 103, 104, 105 will be kept intact. Then when you are joining it with this right table, which is customers table, to join the rows that match what you have on the left table. But in the result, you're going to have everything on the left table present. So in this case now, you have one, it's going to make it and show you customer name, customer email, and phone number. Same thing with 103. These two do not match anything yet, so they won't exist. You're now going to have 104. 104 will exist because it's on the left. But since it doesn't have any, it's going to leave it as no. All of this we know. 152 is going to exist, but since there isn't any corresponding value that matches it, it's also going to be no in the output. So let's see the output. This is what the output looks like. See all the rows in your left table are kept intact. Then it's now going to merge the ones on the right table that have a corresponding customer ID. That's 11, 102, and 103. But your 104 and 105 did not have any corresponding in the customer table. That's why it's leaving it as null values. So this is how left join works. Can go over it again. Everything left will be kept intact in your result. Then it's only going to join the data on the right table that matches what you have on the left table. If not, it's going to leave it as null. It's going to leave it as missing value. That's why I have this as the output. There's a case where you may want to use a left join. And that case is, let's say you're doing data analysis and your main table of interest is the left table. Let's say we're doing movie analysis. My table of interest is this order table. Okay, we are doing customer order analysis. My main table of interest is this order table. Then I just want to get some extra information. They are not that important, but I just want to get extra information. But my main thing, what I'm focused on in my analysis is this order table. That's my left table. So because I just want to get some extra information I can use for my analysis, I just perform a left join. As I'm saying, just join the extra data to the data, which is data because it's on this order table. If it doesn't have any stuff that exists, you can leave it as blank analysis. So
Mr. Ini,
yes.
I'm sorry to cut you short, but really, this thing is cracking so bad. I mean, for me, I can hardly understand you. All of these things we're talking about is new to me. And even if we have to refer back to the video, this is still what we're going to get there. So I don't know. I think we should address this before moving forward.
All right. I think the one thing I can try now is to restart my system because I really don't know what's happening. So
I don't know what is happening, but do you know whenever you're explaining to us, it's clear.
Yeah.
But when you continue with the class, it starts.
So it's only when
it's also clear when we are talking. Yeah. When we are asking
so it's only when I go back to my slides.
I can hear Lovett.
Yes.
I can hear Lovett clearly. Yeah. But it's only when you are talking that it starts.
If Nina is speaking, is clear. If Mr. Gola is speaking, is clear. The last person that just spoke now is very clear. But when you go to this window of PG to explain, then it becomes a problem.
I see. Let me try restarting my system because now I'm not sure what's causing this. It's the first time this is happening. So give me 5 minutes.
Now as you're talking, we can hear you well.
Weird. Maybe Google Teams, Microsoft Teams doesn't like Google Slides. All right, I'll be back.
just before our coach comes back, I was actually thinking that if you guys could contribute money for me, I know a juju man who could solve this problem. Oh. All this one that the man is rebooting and underbooting. There's a juju solution for it, but you would have to contribute money.
Is the juju man going to do it this night?
Obviously, in our express service now, things like this must not be delayed. Me too, I want this man to finish this thing tonight and let us move to another, maybe it's Power BI, maybe it's Tableau. Make we quickly finish this course now.
Istanbul, if you transfer the money, it will not work. Or, you have to see the juju man face to face. If you do transfer the money, no go work.
So is the juju man staying with you, Mr. Bola?
Okay, I keep my peace. I know you people are unbelievers anyway. People who go to do data analytics and this thing, you must be unbelievers. I know. So I give up. I tell the juju man to go. Don't worry, God, don't worry. I don't need it. I told him to go.
Whatever the case may be, I believe that it's like power at the moment, so it's probably trying from its end to.
Okay, I'm back. So I don't know if it's better now or if it's still the same.
We will observe for a couple of minutes, sir. Just start. Just feel free. We really appreciate your effort. Just start and let's go. We'll let you know. We'll give you feedback.
All right. So far, any question about the left join, how the left join works?
If you can go back and explain that left join, because I didn't hear anything there.
Okay. So I said in a left join, your main table of interest is the table on the left. That's your main table of interest. So in your output, you're going to have all the details of the table on your left, which is the others table. So everything here, everything is going to be intact. Okay, so everything here is going to be intact. And what you're going to have on the right table, it's only going to consider those values, those customer ID that matches with what you have on the left. So in the outputs, we're going to have all of these detail 105, 101, 102, 103, 104, 105. Then what it's going to get the right table will just be the details that match the key on the left. So the key here, we have 101, it matches. So it's going to give you the details of John Doe and everything else. You have 102. So that's going to give you the detail of Jane Smith. 103 is going to give you the detail of Mike. Can you hear me? A call, I'm hoping it did not, and it interrupted the presentation. Hey guys, can you hear me?
Okay. Yeah, I can.
Okay. A call came in, so just want to make sure. Good. All right.
Okay, Mr. Ini, please, I have a question. For these joins, the customer, something like a customer ID is a unique value. So when we do the joins, some values won't be captured.
Yeah.
How since they are unique, so what will happen to them? Why does it have to go away entirely from the result of the join?
Okay, it's not like they are going away. Is it, do you mean like 106 and 107 going away?
Yeah, yeah.
Okay,
And here
that's why it's
107,
okay, okay. So the thing is, wait, that's actually a good point. That's a good point because part of the rule of part of the what's the issue? Okay. Okay, so that's a good question because ideally, if you have a
We really beg. We beg for those. We really beg for those whose mics are on to put it off, please. Please mute your mics, please.
okay, from what you mentioned, I know there's a rule for relational database that makes it impossible to impute something like 104 and 105 if it doesn't exist in the customer's table. So let's not focus on that. I want to explain how the left join works. So this is just a dummy data set to explain how it works. So you're asking about why we have missing values here if it's unique. The fact that it's unique doesn't mean it's not going to, the fact that customer ID is unique, it's not going to affect the joining process. It's not going to affect the joining process. The uniqueness is just to assign a unique number to each of the customers and to each of the orders. The reason why we don't have anything here, 104 and 105 in this case, is because on this table, we don't have any 104 and 105. Ideally, in the normal relational database, that won't be the case. You will actually need to have a value of 104 or 105. If not, SQL will not allow you to put it in this table. So that's a rule. That's a rule that exists with relational databases. So the question is valid. Thank you for bringing it up. But for this example, I'm just showing you how the left join works. I'm just trying to make a point with how the left join works. So all the exclusion is done on purpose. So the major takeaway here is that the left join to consider all the values in this orders table. Then if the value doesn't match what is here, like if you can't find, like in this case now, we can't find the customer ID 104 on the customer's table. That's why it's coming up empty here. And we can't find the customer ID 105 on this customer table. That's why it's coming up empty. But the normal rule, like you mentioned, ACID property, there's a property of relational database that won't allow you to even impute this value here if it doesn't exist here. But for now, I'm just using this as an illustration so you understand how left join works, how right join works, how the join works. So this is an example. Does that answer your question?
Yes, thank you.
You're welcome. Real life database, SQL won't allow you impute this if it doesn't exist here. But you can have like 106 and 107 not existing here. That's a different case. So let me explain the right join. Maybe with the right join, you'll now see the difference. So the right join, it's like the left join. Is just now, instead of focusing on the left table, your focus is on the right table. You're focusing on the right table. That's it. So it retrieves the rows from the right table and the matching left table. So everything that is in your right table will be in your output. And the only thing from the left table will be the ones that are matching. This is the syntax where you have right join. So this is your left table prime minister and your right table president. Let's see. So we still have the same example. I just want to explain it. So in this case now, everything in your right table, everything you've seen here is going to be there in the output. The only thing that will change is that you're now going to have matching rows from the left table. So in this case, everything here is going to be intact: 101, 102, 103, 106, 107. And if you want to match it, 101, 102, and 103. So this is what your result will look like. Although there's a mistake here, you should have 106 here and 107. Stay pen. Let me just write it here. 106 and 107. This just depends on the query, the way you write your query, but this is the result. So you still have your 106 and 107 showing. All right, so 106 and 107 will show. I'll have to update this in the slide. So you have 106, 107. Again, everything on your right table will be maintained. Then it's now going to join with the matching or corresponding rows on the left. So that's the difference between left join and right join. That's why people mostly use left join. The only thing they would change if they want to perform right join will just to be to flip the tables. So if they want to perform this query, all they need to do is just use left join, then they move president over here and move prime minister here to still give you the same results. So we don't have people that use right join that much because everyone just focus on their left, the left table. So if they want to perform right join with this, they move the customers table to the left side. They move this to the left, and then they move this to the right side, and then they just use left join at once. That's why you don't see people use right join that much. You just see people use inner join and left join. I have the clear. All right. Donald, do you have any question here so far? And I hope the mic is stable now. It's still difficult to hear.
No, it's okay. It's better now.
Better than it was before. Better, a bit better than it, quite better than it was before.
All right.
Okay, Mr. Ini.
Yes.
Good evening, sir.
Good evening.
Okay. Someone have asked this question earlier, but I just want to get clarity. In the previous class that I joined, when you come to SQL, you usually type that syntax. That's the orders. This exactly. Select from right, and then we'll see it work. But this one is not like already made. So if we should follow this formula, will it come out the same way? That's my question.
Yes, we're going to do this. But before I even get to the practical, I need to make sure you understand how the right join works. We're going to get to the coding part, so don't worry about that yet. Just need to take the final kind of join. So once you understand how it works, we now see how you can do this. So the final kind, that's full join. So full join is basically the combination of a left join and right join. You're doing a full join. So it's going to retrieve all the rows from both tables and include null values for non-matching rows. Let's see an example. So it's going to include all the values. It's going to include 101, 102, 103, 104, 105, 106, and 107. And the ones that do not have a matching row, like it's just going to leave it as missing. So it's a combination of left join and right join together. So this is what the output looks like. you're going to have everything from the orders table, and you're going to have everything from the customers table. If there's no corresponding, if they don't match, like this case, 104, 105, you don't have anything that matches, it's going to leave it as null values. And in this case, for the orders, we don't have anything that matches here and here, 106 and 107, so it's going to leave it as blank. So this is a full join. Full join. Remember, left join focuses on the left table and get what matches from the right table. Let me start from inner join. Inner join takes what is common to the two tables and ignores everything. Anything that isn't common, it's going to ignore it. So you're just focusing on the things that are common. Left join focuses on the left table and takes what is common, merges what is common from the right table. So these parts, these are common to both tables. It takes them. And then right join focuses on the right table. It's going to keep everything that's on the right table. And if there's no matching record on the left table, it's going to leave it as no data. A full join, on the other hand, is going to take everything both on the left and right table, and if there's no matching value in either table, it's going to leave it as null. So any questions so far with what we've done, like these joins, before we can do the answer?
I think that earlier,
Yeah.
when you were talking about the types of join, I thought I saw something like inner, right, left, and then outer. Now I'm seeing full join.
Yes, this is a full join. This is the fourth type of join, full join.
Because if you go to the like the first slide, I think I saw something like outer join, or was it?
On the first slide, first is inner join. That's the syntax to perform an inner join. Next is the syntax to perform a left join. So you use the left join. Third is the syntax to perform a right join. So you use a right join. And finally, for the full join, the syntax is full join or full outer join. Anyone, full join, full outer join.
Okay.
So let's go to Postgres. Everyone has been waiting for Postgres. I know if you want to code, so let's code. So I have to wait for my pgadmin to load again since I shut down my system. So let's start with the film table, since that's what we are familiar with for now. Just want to show you something real quick. I'm going to open this 3 times, so it will be easier for me to navigate between tabs. So I have 3 query tools open. In the first query tool, let me open the films table. So select, let's view everything from the films table.
No, sir, not so fast, not so fast. How did you open your 3?
Just do it, repeat it 3 times. The query tool.
Repeat it 3 times.
Yes.
Let
Right
some
click.
of us also simulate it by following you.
Yes.
Let's
Yes.
follow you.
So when you're done simulating it, let me know. So let me do another one so you just see everything. So right click, query to, it opens a tab, then you repeat it again like 3 more times. So you have all the tabs here, 1, 2, 3. I'm going to close it since I have extra 2. I want to use one of these tabs to visualize the left table, table 1, and I want to use the second tab to visualize table 2. That's to visualize, to view table 2, and then the last one to do the joining. So when I want to show you the columns in table 1, you'll be able to navigate there and view it. If I want to show you the columns in table 2, just navigate to the second tab and see what I'm doing. So the next table I want to open is reviews table. So we have the detail about the movies here. You have the ID, the title, release year, country, all the way to budget. But it's not giving us information about what people think about these movies. That's the reviews of this movie. So I want to merge the two tables together, the films table and the reviews table. So in the second tab, I'm going to now view the reviews table. Let's see what is in the reviews table. Select everything from reviews. Okay, so I can see the primary key, that's PK, to tell you it's primary key for the reviews. And I can see some other columns like film ID, number of users, number of critics, IMDb score. This is the rating of the movie on IMDb. There's the number of votes, the number of Facebook likes for the movie. And there's something I want you to observe. Can you find anything here on this table that can link us back to the film table? Remember, I said before you can join two tables together, you must have a connection between these two tables. So is there anything here that can, you
Yes,
think?
the film ID.
ID.
Which one is it? ID or film ID?
Film ID.
Okay. Does anyone think of, you think there's something else besides film ID? Okay. Okay, it's the film ID. So this film ID is the connection that we need. Let me go back to films table to connect back to this film table. So on the film table, this is the ID, the primary key. And then in the reviews table, this is the primary key for review. So this is not what is going to link us to the film table. This is it, because this is the foreign key. This is the ambassador that is representing the films table. For example, in this case where we have 78, let me use this, sorry, 74. Let me use this since it's the smallest number. This is representing the film with the ID of 74. So let's go back to film ID and look for that movie 74. So this represents the non-story. So if we should merge these two tables together, so where you have 74, you'll be seeing all those other details of title, maybe the non-story and duration and all of that for the movie 74. Now let's join the two tables together so you see how it works. I'm going to use my new tab so it'll be easier for me to navigate between tabs. So we want to merge, which means I'm going to use select all. Asterisk means I want to see all the columns from. Now this part is where you specify which table you want to be on the left side. Let's say I want my films table to be on the left, to be the left table. Can now do from films, and I want to join. Since I want to join, and I can pick the kind of join I want to use, so that's inner join. So inner join. So I'm saying we are going to merge these two tables together before we do anything else. So select from films, then let's join it with the reviews table. Now, you've told SQL you want to join these two tables. The next thing you need to tell SQL is which columns are you going to use to join them together? That'll be the columns that are there in common, the two columns that you have in common, the two tables. So in the first table, let's go back to films. In the film, you have the ID. So here, I'm going to use the keyword on. So inner join on, put in the name of the table, films dot. So which column in the films table am I looking at? That is the ID. Equals, and now go to the reviews table. So I start by typing in reviews. Then what is the column that matches this film ID? Let's check again. So this is it, film ID. So dot film ID. And this is the syntax for joining. I'm going to run this.
Mr. Ini, why do you have the dots before the film after reviews? Reviews dot
Which
film.
one? Okay, yes. I'm saying this is the table, films table. In this films table, I'm using dots. I'm separating it with dots, and I now specify the column name in this film table. So
No, I
you
mean
use
after
a
you
dot.
wrote reviews dot.
This other one. Yes,
Yes.
it's the same thing. Still the similar context. This is the reviews table. Then in this reviews table, the column that matches is film ID. So this is the syntax. You have to use dots to show this is the table name and this is the column in the table. So it's a dot, films dot ID, and then reviews dot film ID. Is that clear?
Okay.
If I go back to the slide.
Hello, Mr. Ini.
Yeah.
Given the hands-on exercise we've just done now, I'm just thinking aloud. Then there is virtually no this thing that one cannot join, because all tables, almost all relational database tables have the ID, and the ID is always integer. It's always integer. So I'm sitting here now thinking, even if there are no relationships, in so much as they will inevitably have ID columns or ID fields. Then are you saying that we can just about join any two tables in so much as they have one field, like the column field, speaking to a common this thing, title, or a common nomenclature? Just asking
That's a very good question. Yes, thank you for bringing it up. because I noticed something. Some people will do something like this reviews.id. Meanwhile, they are joining it on the wrong columns. And if they do this, it's still, what did I press? Sorry. Explain. If they do that, let me run it again. If they do that, it's still going to run and they'll think they have the right answer. Meanwhile, it's not. The stuff is wrong, but they won't know. So I was going to get to this other part, but now that you've asked the question, let me talk about it now. So I'm not going to use this database as an example because this one isn't designed. They didn't design the schema well. So let me use the coffee data to show you something. This is what will guide you as the data analyst, because it's important you understand the schema of your database. So to get the schema, right click and come to ERD for database. Now the reason why I'm doing it on the coffee data is because the coffee data was well created. The films data, they just packed some CSV file, didn't define the relationship, so you don't have that schema string. I'm going to show you what a schema looks like. So you will be able to, it will be easier for you to know the columns to merge. Okay. Since you guys said something about the recording, the previous recording being difficult to watch with the audio, I think what I'm going to do is to send you the recording playlist of the previous cohort, so you'll be able to go through it. Since this other one you're having audio trouble. I didn't know about the audio issue. Okay, so this is taking time. It's going to take time.
You know, last year was everything goes, but this year is not good for anybody. So the class members have gone ballistic now. They're not good for anybody, including coaching.
Oh, I'll check this. Something is wrong with this coffee data. Let me try my local database. I'll get back to this. Let me check something, because this relationship is incomplete. Same thing here. Okay, this relationship is incomplete because customer isn't, they are not showing the relationship with customer. Let me just explain. Let me explain what we have so far. So this is an example of a relationship. You can see there's this line connecting the staff table. This is the staff table to the sales outlet table. Staff table to sales outlet table. And there's this line here. So this means 1:many, meaning one staff can belong to different sales outlets. Think of sales outlet as different branches where they sell stuff. So you could have a staff belonging to many outlets. Maybe they can assign you to multiple sales outlets. And now you see this staff ID. Let me zoom in. Okay. So you see this staff ID. this is the primary key for this table, yellow. And then this is sales outlet. Sales outlet has its own primary key, which is outlet ID. And then there's another key here, which is gray. So this represents the foreign key. Now this line tells you that this is the relationship that exists between these two. So when you see staff ID, this is it here in this other table. They used a different name, manager ID, but because of this relationship now, you can tell if you want to merge these two tables together, you're going to merge them based on the staff ID of this table and the manager ID of this sales outlet table. So this is what will guide you so you know what to merge. Same thing applies here. We have the product type ID. This is the product type table, and this is the product table. So you could have, this is one to many. So you could have many products belonging to one product type. And this is the primary key, product type ID. If you want to merge these two tables, you will merge it based on product type ID of this table to this point, product type ID, which is the foreign key here. So this will guide you on knowing what to join it on. Let me go down. Okay, let's stuff no hungry. So another thing that exists here, product and sales details. There's the relationship between the product table and sales detail. That's because you can sell different products. You can sell many products. So this is saying one product, that's one is to many. One product can be sold many times. And you can join these two tables together. You use product ID and product ID here. So this is the foreign key on this table. So it's this schema that will guide you. Now I have to figure out why this schema is not complete, because customer isn't connected to, customer is supposed to be connected to sales transaction. Yeah, customer and sales transaction is supposed to be connected as customer ID to customer ID. Yeah, even the outlet ID, they should be connected. So something went wrong during importation. Okay, I think it's because I was using a subset of the original data, because this database is actually really large, it's really big, and it takes a lot of time to import it. So I took a subset, and in that subset, I must have cut the code to define this relationship. So don't worry, I just want you to see how to connect them. So this schema will guide you. So you won't come and start, where are we? You won't start making this kind of mistake. If you check the schema, you should see a better setup. But this film's database doesn't have that schema defined clearly. Let me show you what it looks like. It only has the table names, or the relationship isn't showing. It's just a sample database for now that we are managing, but the coffee data is clear on the relationship. Yeah, this is going to take it time. Let me go back. So now with schema like that, that's what is going to guide you to know the columns you're going to use to join them. So in the films table, you're going to use the ID column, which is the primary key. Then you join it to the film ID. The film ID. Yeah, the film ID. So any questions so far on the schema? So I can actually start doing the relationship. Any questions so far? This time if I want, I can define the relationship myself. So, oh, I made a mistake. Okay, wait. What? My bad. Let's delete this. Hey guys, any question? Okay, so no question yet. Actually, this maybe later I'll define the relationship for you. Let me skip this so we won't waste time. It's almost 10. We've done inner join. So again, I said, let me just do this quickly. Said if you do not use don't specify anything and you just use join like this, by default, it's going to perform inner join for you. So still the same thing. Now let's try a left join. So this is the syntax for left join. All you need to do is change it to left and SQL will automatically perform a left join. So let's run this. And since this is taking time, let me just tell you in advance, all the record, like the results here, it's going to be the same. Like the results we have for inner join, left join, right join, and full outer join, they are all going to be the same. Do you know why they are going to be the same? Can you guess why? That's for this example. Okay.
I think because there is no missing value.
Exactly. You're right. There are no missing values. Like on the films table, we have all the movies are complete, all the IDs are complete, and on the reviews table, all the IDs are complete. So if you run all of them, you're going to get 4968 because everything is complete. So even if you perform a right join, although I can't like scroll down yet. Yes, so still the same thing. And then let's perform a full. You can use full outer join or you can leave it as full join. SQL is still going to understand that what you're trying to do is a full join. So still the same number of records. Right. So for us to see the difference, I brought in another database here. That's this country's DB. Just an example. So this basically has information about different cities, different countries, population, economies. Let me change this. I'll close this and open a new query tool for this database. Remember, this query tool that I opened initially is for the film database. That's why you have film here. So to open a new query tool for this country DB, you actually need to right click and select query tool. Now you can see countries DB. Let me close this. Don't save. So let's go to countries DB. Over here, countries DB. So I'm sure I'm in the right place. So let's select everything from cities. Okay, Abuja. I think this isn't the database I want to work with. The one in the slide is Prime Minister and President. Oh. Let's just see what we can do here. Let me check countries. So I have name, the name. In this case now we have the name of the city as the primary key because you can't have two city names. I don't think there are two cities in the world that exist with the same name. So I think that's why they used it as primary key. Let's check the countries. Okay, we have the country code. And in this case, the country code is the primary key. And then we have the name of the country. What else? Okay, let me open this to different. Let's view the cities here. From cities. Okay, now I have the name, I have the country code, the proper population, the city proper population, the metropolitan area population, the urban area population. That's for cities. And then for countries, we have the country code as the primary key, the country name. There's nothing like city here. So if we want to join these two tables together, what do you think we can use to join them? Looking at it, this is countries, and these are cities. Can you identify anything we can use to join them together?
I think we can use
Country
code.
code.
Perfect. Country code. Can use the country code. And let's check. Cities has 236 rows. This other one has 206, meaning there are some values that are not common in the two tables. So let me open another query tool so we can try merging them. Okay, so select all the columns from, let countries be our left table, and let us do an inner join on cities, and we now need to specify the columns that they have in common. So on the countries table, we want to join them on the code, country code. So this is the primary key here. For countries, it's code, countries.code equals, then the next one is cities. Find the corresponding value. So in cities, it's called country code. Or if you're struggling to understand it, it's totally understandable. I mean, you've actually come this far already in just 3 weeks. Things like this, it takes longer to learn it. You should be proud of your growth so far. So I don't expect you to put that pressure on yourself to learn everything and understand it by force in 3 weeks. Just give yourself time to practice everything. That's the truth about this. You have to give yourself that time to practice it.
Thank you.
You're welcome.
Thank you. But the total rows are now complete.
This
230
is 230. This is 236. And this other one is 206.
It's going to be pretty, if we're picking data randomly from, say, free data sites, it's going to be very challenging to join. And you know why? Because fundamentally, from where I am now, with my little understanding of what you have explained, the schemas of the tables must have been prepared in a manner that they are related to, say, a particular company that has, say, different departments, sales department, production department. So it's easy when that company is building its database to have a schema that will make the data generated from those departments to be able to be used to be amenable to be used for analytics. But now that we are going to pick films somewhere, we are going to pick it's naturally going to be challenging. That's my take.
Yeah. Let's use the coffee data instead. Because looking at this, I understand why the value is 230 because of their like repeated country codes on one table. So let me just use this one that we have the schema predefined so everyone will follow. Let's use the coffee data. Basically, for your project, you'll be using coffee data and films. So let me just start coffee data so you get familiar with it. So coffee data it's basically for a company where they sell coffee. And this company, they have different branches in different parts of, let's say, the world. Let me close this. Let's go back here. So they sell different kinds of coffee, different kinds of products. They have different types and they have different customers. So everything is organized. They have their customers and there are different sales outlets where they sell this coffee. They have different staff. I don't like the fact that this schema is not complete. But let's just continue. I don't work on it now. So let's do something. Let's use staff and sales outlets. Let's just see that. Okay, let me check something else. Customer and sales transaction. Yeah, let's use customer and sales transaction because we have customer ID here. This is similar to the customer and orders table we were looking at. Let me quickly define the relationship here. One to many. So I'm using customer table, customer ID. Reference table is sales transaction and customer ID is the primary key. Okay, so I've quickly defined that. Oh, I made a mistake. It's supposed to be 1:many. Sorry about that. Let me click this 1:many. Customer ID, customer. Don't worry about what I'm doing now. It's not something you're supposed to bother yourself with. So this just means one customer can make many sales transactions. So this will just guide you in knowing how to connect them. Customer ID to customer ID. Okay.
You said we shouldn't worry about that, and you're saying it will also guide us. So how do we?
No, I mean, don't worry about creating this. I'm done creating it. Yeah, good one. I mean, don't worry about this creation, this stuff I'm doing. On the normal, it's supposed to be complete. But I don't know what happened here. I think during importation, that part didn't allow. What you should use is you can use this as the guide. So I'm creating it so you see how it works. I'll create the other ones later. But for now, let's view the customer and the sales transaction table. So select all from customer. I think this is customers. Okay, customer. Okay, so these are the customers we have. Kelly K, email address, registration date, phone number, gender. Let me open another query tool so we can check the sales transaction. Select from sales transaction. You can check the table name here. Sales transaction. No, we have 9 minutes, but let's just see if we can finish this. Okay, so these are the transactions, and just like the other table and customer table, you can see the customer ID for customer 0. Okay, so customer 0, we have missing data, so let's not worry about customer 0. Which other customer do we have? Oh, we have 13,000 records. This may take a while. Let me not bother with that. Let's just join, because if you keep going down, you see details for other customers, which means customer 0 has made a lot of sales transaction with them. Over 4,000 sales transactions. Let me create another query tool for the joining. So now I want to merge the two tables so I can see the details like the customer name, the customer transaction, all the stuff should be together. So let's start with selecting everything from customer, then inner join sales transaction. Now need to specify what they have in common, what these two tables have in common. So customer has customer ID, and sales transaction has customer ID. Let's run this. This is for customer 0, and customer 0 information is missing. That's why. Let me see if we can filter this and remove customer 0. Where customer ID is not 0.
Sorry, Mr. Ini. How do you highlight in this PG, please?
Which place?
Yeah, this highlight. How do you highlight it? Because if it's in Excel, you click Control space.
So highlight this place.
Yes.
I'm using my mouse, just holding and dragging.
Okay.
Yeah. Sorry, need to specify the table name where customer ID, because we are working with two tables now. So you need to know it's asking which of the table is it considering. I don't know if you took note of that error we had, because I did customer ID, which is the normal thing we do, the column name customer ID. But now we have two tables. These two tables, they both have the column customer ID. Customers table has customer ID, sales transaction table has customer ID. So in this case, SQL is going to get confused. This is another very important rule. So even if you don't get it now, let me just say it so it's available in the recording. When the two tables should have the same column name, when the two tables should have the same column name, you now need to specify which table you're working with so that SQL will know, okay, it means customer ID from sales transaction table, not customer table. Because in this case, I have customer ID exactly in customer table, and I have customer ID, the same column name in the sales transaction table. So if I'm doing something like this, SQL will get confused. See now, column reference customer ID is ambiguous. That's because this table, this column name exists in the two tables. So it's not sure which of them you should consider. That's now where it's up to you to now say, okay, I mean the one from the sales transaction table. Then you run it. Then it gives you your answer. For the sake of the recording, let me just continue. The same thing applies to the select statement. Okay, let's see. We have customer ID here. If we go again, you'll see we still have customer ID, but two of them are from different tables. So there's that repetition. Let's say I only want to view the transaction date and the customer ID. So in the select statement now, I don't want to view all the columns. I want to view customer ID and I want to view transaction date. Let me run this. I'm also going to have that error customer ID. Why? Because we have two customer ID, one from customer table and another one from sales transaction. So if I'm specifying it here, I need to show, okay, what the one I'm talking about is the one from the customer table. You can see I can leave transaction date as it is and not specify where transaction date is coming from, because transaction date is not in the customer table. So SQL will know, okay, it means the transaction date from the sales transaction table. Don't worry if this is sounding a bit too much. I understand. You guys are already doing well getting to this level because this is intermediate SQL. This training data is intermediate SQL. So I understand. Don't worry, take your time, go through the recordings. I know this is our final class. After everything, you can take your time and go through the SQL recordings so you understand it. Go slow, go step by step. But let me just give all the information here so when you're reviewing it, it will make sense later, even if it doesn't make sense now.
Thank you for the speech that you gave. I hope this, since you understand that we've not assimilated it very well, it will not be among the assessments.
Yeah, that's a good question.
Take your time with the assessment. Take your time with
it. It's not even so much about the assessment for me. To be honest with you, number one, we weren't taught how to create a table, we weren't taught how to update a table, we weren't taught how to delete, we weren't taught how to, okay, you've taken us through, you've taken us through,
go on.
Fortunately, you've taken us through how to use one of the most popular graphic user interfaces in structured query language, that is PG-admin4. But in most of the places where, trying to do my private reading and whatever, I see them using Postico, maybe I see them using other, in fact, most times I see them using CLIs, and I'm thinking, this is me, Bolaba, and I'm thinking, if I were to be applying for a remote job now, and somebody just sends me some of the things I've seen outside the context of what we've been taught, can I handle it? So I'm having that issue, that element of, and I hate maybe because I like to be very confident about the things I know. So this course we finish now with me feeling iffy somewhat. Thank you. That's just it for me.
Thank you very much for saying that. Thank you. Because the next part of this was I was going to talk about all of that. Someone else wants to say something.
Okay, I wanted to say something. In all the classes that we've been doing with all the how to input the code and everything, or run you've never taught us, like, if you're doing a job, this is how it comes out and how you save, because if you do this other one, then you go back to do the other one. How do you save to pile up your work and make it more presentable?
How to save? Okay, to save your results.
Yes, because if you do one table, then you rerun the select from, and the other table has gone off. Now, how do we save each of the work when you want to do it, so that you can, this is this, this is this, this is this?
We have portfolios. We have portfolios. Sorry, Ini. We've been taught to build our portfolios. We have GitHub, Wix,
GitHub.
LinkedIn. I said GitHub. GitHub, LinkedIn, and you know what? In other things that we've done, we can actually put the links or the listing of those. Of those assignments or assessments there. So what can I exhibit to show?
There, but if you understand what I'm trying to say is that each of the work you're doing, if you have to put it on GitHub or LinkedIn, it has to be a complete work. But while you're still working on it in PG-admin4, like if you have like 4 or 5 questions, you're working on one, and you're going back to the table to select the other question, to do the other question. Now, are you saying that we should save the first one, go back and do the other one, then save the second one, come back to do the third one, then save? Is that how it goes?
All right. Okay, so let me take the first one. So what you're saying about the creating of tables, updating tables, dropping, yes, you are right. And that is if you're learning Postgres, that's when you're learning Postgres as a whole, you're learning the whole database concept. So the thing with Postgres or any of these relational databases that they are really broad. And if you are learning data engineering, maybe you want to do data engineering, how to create, that's where I would bring in all those stuff. Like you start by focusing on how to create the database, how to update it, how to drop it, or you're learning about database, purely about databases. That's where that part comes in handy. Like that is where you learn all those things like create database, drop, update, you learn it well. So the thing about this course is that it's focused on Postgres for data analysis. Postgres is broad. There are a lot of things to learn, including what you said. but there won't be time to cover it. And since the course is specifically focused on Postgres for data analysis, it's my job to show you how to use it for data analysis. So you see, it's a really broad tool you can use to do different things. There's the part of creating database, like you mentioned. There's even the part of learning about database concepts, things like normalization, all those stuff. Well, that comes in when they may be doing Postgres for data engineering, things like that, or you're learning Postgres as a database tool on its own. You just want to know how to use Postgres, every part of it, whether the data analysis, and that will take a while to learn, take a long time. So when I was designing this course, that's why I didn't put it there, because it's not it's not like that major stuff when it comes to data analysis. You're there focusing on analyzing data. So your job is to, as a data analyst now, is to take data that exists in a database and learn how to analyze it. So this course is focused on Postgres for data analysis. That's why I didn't cover all of that. And you also mentioned something about, you said, you are looking at other courses, other tools, yes, and they are using other things. Maybe they are not using pgadmin 4, they are using other stuff. Maybe they are using SQL Workbench or maybe BigQuery. Cool, good. It's a good thing that you're looking at all those stuff. You're exposing yourself. It's important to expose yourself to all these things. One important thing is that all this stuff we are learning now, it's not something you can learn in 3 weeks. It took way longer to learn this stuff. It took years. It took years to learn it. SQL, databases, all these concepts. It took years for me. It took years to learn it. And so for a 3 weeks course like what we're doing now, this feels like a crash course, because on a normal day, I wouldn't want to rush anyone the way we are doing now. Like, see, we're in all the way in SQL joining, and you guys have come this far in just a short time. But it's more of a crash course. What we're doing, it's a crash course. And all those stuff we are learning, they are good. Like pgadmin 4 is what we are focusing on. Out there, you may learn other tools, like you may have to use BigQuery, you may have to use SQL Workbench if you are working with MySQL database. But the main goal, the most important thing, which is what I'm focusing on in this course, is for you to know how to write SQL queries. This is the main thing. So that's why I'm not putting too much emphasis on the tool. When I'm working, I'm using like writing SQL code. I may not be using pgadmin. In fact, I barely it's not the time I use pgadmin. I'm using different tools every time based on what I'm working on. But the most important thing, which is what I want you to take away, is knowing how to write SQL code. Because if you're using another platform like BigQuery, some things will differ, but SQL is SQL. The only thing that you learn is just maybe you add some additional stuff. Maybe BigQuery, you may have to use public here before writing the table name, all those kind of stuff. So that's why I'm not putting much emphasis on the tool, because when you go out there, you're going to learn different tools. But one thing you need to know is you need to know how to write SQL codes. So that's the priority. And then as an extra for this course, like what I'm doing, you can't learn there's still a lot more to learn in SQL. Even this SQL for data analysis, there's a lot more to learn. If not even, there's the intermediate part, there's the advanced part. That's just for data analysis. So I understand you guys' dilemma, like what you said now, using CLI tool. CLI tool, that's you're using command line to be coding. As I'm basically on Linux, because I can use more of terminal, like what we're doing during that video where I showed you how to import database. You're using PSQL. And PSQL is another aspect. If you do not want to be querying or writing queries like this, you can write it in command line too. So that's CLI. So what you're doing is not a waste. There's still a lot you have to learn. And in my slides, you'll notice I was going to talk about this later. I've added resources that you can use to learn other things about SQL, because what you've learned now, this is the foundation, and it's going to help you learn other things. You're going to build up on what you've learned so far, and it will be easier for you. Again, another major goal is for me to teach you the basics Now with these basics, when you go out there to look at any online course, you won't be lost, you won't be confused. You have a grounding, you understand the basic stuff, select from, inner join, you know how the stuff works. So as you're learning anything new, it's easier for you to build up on top of it. It's not the one where you're starting from scratch and you don't understand any single thing. So the goal of this 3 weeks course is to help you with that. Okay, I mentioned I've added resources to this slide. And yes, the song said something about saving work for presentation. That's a good one. Good one. Well, let's see. Normally, let's say you've written your code like this. What you can do is to create a comment here and you put in what this query is solving. Maybe you're trying to join sales transactions table with customer table. You can keep it that way. Then if you want to write something else, this is for your work, your portfolio, maybe GitHub, GitLab, or you want to post it on LinkedIn. Then you can go ahead and type maybe the next thing, the next SQL code. I know I've been doing it one by one. One by one is to show you how to do different things, and I don't want to like put plenty codes here so you don't get confused. If I start putting different codes with different, I keep typing long codes, different examples, you guys will get confused. So you can maybe, that's why you end this with a semicolon so you know that this part is done, and then you now type in the next part, maybe view all the data in the product table, and you can continue, maybe select star from product, sure, and you can save the file. You can save it to maybe practice, what's going on, practice.sql. All right, let me save it to desktop instead. Let me save it here. So practice.sql, and you have it here. So you see I've saved it to a file now. Now this file, I can upload this file practice.sql to GitHub. So you can put all your examples, everything, write all your codes and save it. And this file you're going to upload to GitHub so you know this is your portfolio. What else? Let's see. In the other part, maybe you've done some kind of analysis and you have a table, you want to save that table. You come here to save results to a file. Click it, it's going to download it as an Excel or CSV. Is it CSV? Yeah, it's going to save it as a CSV file. So you have the output of your query. Maybe you can now take it to Excel and continue doing your analysis with Excel, and you do visualizations. But mostly, like if you want to showcase your work on LinkedIn, what I usually do, in my case, what I do besides saving it to a file, I usually take screenshots, which is what you're going to do in your project, because in your project I gave instructions on how to do all of that, because you're definitely going to showcase your work out there, showcase it to people, say this is what you've done on LinkedIn. If you check the previous quotes, okay, I don't think you can check it, but that's what they did. They screenshotted their work. So on Windows, there's a tool known as what's the name? Is this Snipe tool? Yeah, Snipe tools. You can check this out. It allows you to take screenshots of your screen. So what you can do is, let me use mine. There's another stuff on your keyboard known as print screen. In my case, print screen. I can take a screenshot of this. It's basically what I did for my project. Let's say my IBM data science professional certification and my IBM data engineering professional certification. It's what I did. Like when you do work on the project and you want to present it, there's no other way. The only thing I had to do was I had to take screenshots of my work and then I uploaded them on LinkedIn so people be able to see my codes and the results and all those stuff. So it's another way you can do it. Again, it's 3 weeks, and to be honest with you, 3 weeks is not enough for you to learn what you need to learn. It's just enough for you to know the basics, know the main thing. Even in this course, I designed it in a way that we will get to the intermediate stage. So at this point, we've passed SQL basics and we've entered the intermediate SQL, and that's far, that's progress on your part. I'm trying to push in as deep as possible so you guys won't be lost when you get out there. I know I can't continue this. Let me just stop the class here. We're mostly done with all the kinds of join. Let me go back to the slide. So after all the joins and everything. So this is a demonstration joining data exercise. So it's better I'm just continuing from here because now basically prepping you for real world stuff. Okay, wait, so far any question with what I said? Because I know you were really iterating on the creation of SQL tables, creation of updating. Yes, that part is valid, but it's mostly when you want to focus on data engineering role or you want to learn Postgres, like you're learning Postgres as a topic on its own, not Postgres for data analysis. So for Postgres data analysis, moving straight to the analysis, because I'll just show you that a table exists, like when we are connecting to a remote server and how to analyze it. Even most SQL courses you find online, like when you want to learn SQL for data analysis, most of them won't show you how to do all those creation, except you are learning SQL like Postgres on its own. You're taking a Postgres course, full Postgres course. That one, they'll show you how to use CLI tool. They'll show you how to create database. They'll show you how to do things like normalization. It's not specific. They are not going into Postgres for data analysis. If they do, they'll just show you small stuff like how to select your database. After selecting, they'll show you how to do alias, how to select columns, and that's it. That's all they are doing. Then they continue teaching you the main thing. But for you guys, data analysis, your main goal is to know how to use SQL to do data analysis. So for any questions, if I get to this part of the course. All right. So for real life projects you may be working on, these are just some important tips I have to share from my experience. So the first thing is you shouldn't be scared of the questions, like the questions they may give you, because your clients may have some questions, they need answers to those questions. They need answers to those questions, and you're trying to analyze the data so you can help them answer some questions. Some questions will be tricky, some you may not know how to approach it, but it's all part of the data analysis process. You're going to hit dead ends. Dead ends is like, okay, you think this is how to solve it. You start doing the analysis and you now find out, oh, this is not the right way to do it. You now have to go back to the beginning. So it's part of the process. The frustration too is part of the process. You will get frustrated. I'm not going to start sugarcoating it like, oh, data analysis is simple. You do this. Even me doing data science, doing data analysis, doing machine learning, and someone is come to say, data analysis is easier. I'll just be looking at the person like, what do you mean? Because to get to a point in data analysis where it's difficult, I basically tell people to pick your poison, because anything you want to learn, Whether you want to learn data engineering, you want to learn deep learning, you want to learn this, everything you want to learn, they're all difficult. Just pick the difficulty you can manage. Because you have some people that are like, I don't want to do AI. AI is too technical. Let me just do data analysis because it is simple. And they say things like that, I'll just be laughing at in my mind. I won't actually laugh at them. Because when they say it's simple, when they now get to the parts where it's difficult, they're now like, okay. So it's all part of the process. Enjoy it. You're basically like a detective, Sherlock Holmes. And the more you dive deep into the questions, the more you learn. Yes. Another thing is you shouldn't be scared of asking questions. Don't be scared of asking questions. Or see, early on in my career, I used to be scared of asking questions. Why? Because it feels like if I'm asking questions, they'll start thinking I don't know what I'm doing, or I'm asking too much questions, I'm doing this, I'm doing that. Don't be ask as many questions as you want. Even if you are there in that meeting with your stakeholder and you have 100 questions, ask all of them. Why are you asking questions? So you can do your client's job. They won't tell you to do one thing and you're gonna make a mistake and do something else. You need to be sure. You need to make sure you understand what you're working on. So ask as much questions as you can. Even if you're taking the Google Data Analyst certification course, you'll find out that there's a whole course dedicated to asking questions. I think that's either course 2 or course 3. A full course just on how to ask questions. That's how to ask smart questions. So maybe you can review that course later on Coursera. So it's when I went through that course, I was now like, oh, that means this is normal. It's part of the process. You should ask as much question as you want, so you understand what they want, what your clients want. And if there's anything you don't understand, you can also ask like senior data analysts that may be working in your company, or you could ask your mentor so they can explain things to you. If it's something about the database that you don't understand, you can talk to the data engineers that worked on it, that designed it, let them explain stuff to you. So ask questions till you understand. The last pointer is take your time to understand the question and break it down. The questions. Okay, questions like the questions they want you to solve. Sometimes the question may be easy, may just understand what they mean quickly. That's fine. Other times the questions may be complex, may be really complex questions, and you need to know how to solve it. It will get to a stage in your career where all the stuff we are learning, join, group by, they are like small stuff. You have them in your fingertips. You really know how to use them. That won't be your problem. You know how to use all the stuff. Your problem will be understanding the question and knowing how to use these tools you've learned to answer that question. Recently, there's a contract I got, and the contract I was helping this company to optimize their waste collection and waste dumping process. And I had to sit down for 1 hour. Okay, not even one. I think the meeting lasted over 1 hour. And we were just sitting down there trying to figure out how to solve the questions. They had some questions out they wanted to know, like the optimal number of waste skips to keep in the different branches of their company. And we are sitting down brainstorming, trying to figure out how to answer all these questions, how to do the analysis. So you see, the analysis is not the problem. Now need to figure out how to answer it. We are taking our time to break down, discussing the whole stuff. We're not rushing into coding. You're sitting down to understand what to do. And that lasted for about an hour. And then it's going to be experimental. You try this, it may work, may not work, and we'll go back to the drawing board to see how we can answer the question. So take your time to understand the questions and break it down as much as possible. If you can just break down the question, start small, then build it up. Yeah, so basically you can be like this guy. It's get to a point where you talk to this guy. You have all your wall or your whiteboard and you're planning everything on the wall, just trying to understand what you're doing, make sense of your analysis. It could be like this cool FBI agents, sipping coffee, looking at the data, the plan, and trying to see if you can retrace your steps to solve some questions. So I think that's about it. This part was just to show you some questions, things that may come up, how the questions may be presented, and how you can solve it. So let's see. What's the time? Let me be sure. So I was going to solve one of this, and number two that says how many people, actors, directors worked on the movie Batman vs Superman: Dawn of Justice. Let me see if we can try to solve this. Let's give ourselves 5 minutes before I go to the next slide, just quickly, because this is a sample question. I just want to break the thinking process down. For example, okay, so let's say this is the question we're supposed to solve. They want us to find out how many people worked on the movie Batman vs Superman: Dawn of Justice. It's not straightforward. Now, this requires that we think. Oh, sorry, I'm in the wrong place. Let me cut this. It's the films database supposed to analyze. So let me open this in the query tool for films. So yeah, they want us to find out how many people, both actors, directors, worked on the movie Batman vs Superman. First things first, I'm going to check out all the tables in this database so I know which one to work with. So I start by selecting from films. And I can see all the movies. But I want to count how many people, so I know it's not just going to be the films table alone, because films doesn't have any detail about the people. So let me check the people table. So now this is you're breaking down the problem to see how you can solve it. So the people table doesn't even have any information about the film. There's nothing to link it back to film, just a bunch of people, their birth date and death date. So let me try roles, the roles table. Now in the roles table, I can see the role, director and actor. You can see the person ID. Now this person ID is going to connect me back to the people ID, the people table. You can also see the film ID. So for this film, the film that has an ID of 1, you can see there are like 4 people that worked on it. Although this is not real life, it's not like it's 4 people that work on this movie. It's just a sample data set. And for this other movie with the ID of 2, I have like 4 people. So this means I need to join, since now I've gotten the first thing I need to do. It means I need to join my films table with my roles table. So that's the first thing I'm going to do before I even move on to doing any other thing. So I can continue from here. Select all from roles. So that'll be inner join, just joining it. So join. By default, if I use join without specifying anything in front, that's going to be inner join. So join with films. And I need to specify the column on, like specify how I'm joining them. So roles This is the roles table and it has film ID. Roles film ID equals to films dot ID. I remember in the films table, it's ID that they use. So let me run this. Okay, I've been able to join them. And as they are joined now, I can see ID, film ID, person, this is the director, and this is the movie 1, 2, 3, 4. Okay. But they want me to count how many people worked on the movie. They've given me the movie. So this is the movie I want. So let me find this movie, which means I need to filter. So I'm going to do where I like. Now this is where you start remembering all the tools you need. I want to filter, so I'm using the where clause. Where title, so title of the movie. So where title I like. Let me say Batman. I want to find the movies that have Batman in them first. I'm just experimenting. They want a specific Batman movie. I want to see all the movies where Batman was there, all the Batman movies. Batman and Robin, Batman Forever, Dark Knight Returns. So this is the movie they want, Batman versus Superman, Dawn of Justice. So see, this is a step-by-step analysis. Not like I know what to do at first. I'm taking my time. I'm asking myself questions. How do I get there? How do I do this? So I've seen the movie they want, Batman versus Superman, Dawn of Justice. I will copy this, and now I can actually filter by exactly this title and clear this. So now I found the movie Batman versus Superman, and I now need to count because they're asking how many people, that's actors, directors, worked on the movie Batman versus Superman. So I now need to count. Looking at it here, I can already tell 4. 1, 2, 3, 4. It's easy to count, but I still need to write the query for it. So that will now be count. Now I remember the aggregate function count that is going to help me do this count. So I can run this. And I get my answer 4. I can use an alias to make this more descriptive for anyone seeing number of people in Bat versus Soup movie. I know there's a long alias, but let's just go. It's number of people, 4. And so now I've been able to answer that question. So you can see the step-by-step process. Some questions won't be that clear or that direct. They won't be that straightforward, which means you're going to have to think, sit down and think. Most of your time will be on thinking, problem solving. You write down how you want to approach it, how you think you can solve it before you now come and code. Or you can be coding and be talking to yourself, be asking yourself questions. How do I do this? How do I do that? So it's just one example I want you to see. There are kinds of examples, like they could ask you between this year, did USA make a higher movie profit? They make higher profit than Mexico? Those are questions that you could come across, and I have to sit down and think, what does this question mean? What are they trying to find out before you now do your analysis? Maybe this part now you use filtering to filter it to show movies from 2000 to 2016. Maybe now you can also filter to only show movies in USA and Mexico. Then you're trying to calculate profit. you know you have your gross and budget, you now subtract so you can find profit. Then you can maybe find average profit between USA and Mexico and see which one is higher. That's just an example. See the way we are thinking, taking things step by step. So yeah, the next part, which is the important part for you. We've not, like, there's still a lot more to learn SQL for data analysis. And there are some resources I recommend. You can go through this one, SQL for data analysis. It's on Udacity. There's also Intro to SQL on Kaggle. There's the Advanced SQL on Kaggle. There's SQL in W3 schools. There are other resources you can use besides this one, but these are just a few I'm recommending to you. And the cool thing about it is, since you've gotten up to this stage, it will be easier for you to pick up from here. Like when you go through all these courses, you won't be lost. You won't be lost. You have an idea of what you are doing, what you are learning, because you've learned that basics, you've gotten to this intermediate stage, and now you can continue from here. 3 weeks is not enough. 3 weeks is still not enough for you to learn it, because each of these tools you've learned, you have to actually go deeper into them. You need to go deeper, or just focus on building projects. Like, use this knowledge you've gained so far and start building projects with it, like the project I'll be giving you to work on. What recruiters want to see out there, they want to know that you know how to use SQL to solve a problem, you know how to use it to answer questions. It's not just about learning, and you can't use what you've learned to do anything. So projects are very important, because work on as many projects as you can. You can start with the two I'll be giving you. The other the project is better, because you're going to learn more from it. It's the project that will push you to learn other things you never knew you needed to know. So if the project is difficult, enjoy it. That'll be a good opportunity for you to research, do a lot of research online, learn how to Google things to help you with your problem solving skill. What else is there? So you can check out any of this course to go deeper into SQL. And yes, so you can also connect with me. I have a YouTube channel, Team TechDom. You've already seen it by now. It's why I upload classes recording, although I upload it to a private playlist. So you can subscribe to my channel to keep up with me. Hopefully this year I'll be releasing content in stuff like Python, R, and SQL, data science generally. I hope to continue this year. Oh yeah, and this is my other personal YouTube channel. I just share inspiring messages on the gospel to inspire people. And you can connect with me on LinkedIn. If you also feel free to give me a recommendation. If you don't know how to go about recommendation, giving people recommendations, you can reach out to me on WhatsApp and I can guide you. And you can follow me on Twitter. Available on Twitter. So this is the link. These are the links there in the slide. I've updated the slide. And that's it for this course. Yeah, that's it for this course. Just 3 weeks to learn as much as we can about Postgres for data analysis. So I understand. If you want to learn all those stuff, like how to create a table, yes, I can recommend resources. W3 schools, let's even check that out. So you can see everything here, intro, or SQL, RDBMS, started by analyzing, getting data from the table. So this one, they already have a server you can use, and see all those other stuff you're asking, like insert to. So you can see the syntax for this. There wasn't enough time to go into all of this. All this stuff isn't really what you need to focus on as a data analyst. It's mostly people that want to go into that data engineering field and take time and learn it. when I was learning data engineering. I spent a great deal of time into all of these parts. Yeah, so SQL, there's something else. SQL is divided. There are different languages. There's the DDL, data definition language. There's data query. Data query is what data analysts will be using. There's data control. Let's see, SQL, DDL, DML. Yes. So let me answer that question again. There's a different way, different things. So look at this. There's DDL. Like when you're looking at SQLs, there are like SQL commands and SQL sub-language commands like DDL, DQL, DML. So basically, DDL is data definition. That's what you're asking about. Things like creating tables, yes, dropping tables, altering, renaming, all of that falls under DDL. So DDL wasn't the goal of this course. If you're going into data engineering, basically, yes. And then there are things like DQL query. We've been querying our database and we've been manipulating. Where have we been manipulating? No. We've been querying. What else did we do? Okay, yeah, querying. So the querying part is what data analysts focus on. All these other ones would be like database administrator, like DCL, the person that is in charge of administering the database, monitoring the database, making sure everything is okay, database. And so it's broad, it's really broad. So you control the kind of people that have access to it, data control language, people that have control to the database, like the issue I was having where some people were going to the server to be creating new database and be deleting some stuff. Now, database administrator will like do things like grant permissions, revoke permissions to make sure only certain people can do certain things to the database. So I hope this guide has like given you an idea of things in SQL. If I keep going, I'll start talking and teaching you everything, everything here. So any question, contribution, anything you like to say or add?
So please, will you drop the PowerPoint slide for us after the class?
Yes. Do you have the old link? Do you have the old link?
Yes.
Yeah, it's still that same link. It's been updated.
Thank you, sir.
You're welcome.
Whoever has the old link should please help us repost so that we don't go finding it.
Okay, I'm trying to see if I can find I'll share the project with you tomorrow. So let me end there. Right, guys. So what's up? Any concerns? Anything you want to know? Maybe how to move forward? Anything like that? Confusion? How this what I said answers your questions.
I have no concern, but I just want to say thank you for your time, your patience, and your listening ear. You, at least when I complain, I don't, you pay attention, or whenever I ask for something, at least you make out your time to respond to it. Thank you very much. I appreciate that.
You're welcome.
I fully support the lady's observation, remark, and appreciation. I join you've been wonderful in one-on-one and your responses. You're quite a very responsible and responsive human being. I really appreciate that, sir. Thank you.
Thank you. You're welcome. Okay, so if you need help with any other thing, you can still reach out to me on WhatsApp or on LinkedIn. My details are there in the slide. You can connect with me and I'll respond when I'm free, because last week I was actually busy back to back. I didn't see that coming. So when I'm free, I'll get back to you. What else? Everything you need is there on the slides. Yeah, for the project, I encourage you guys to collaborate as much as possible. If there are things that you don't understand, please ask each other. The other goal here is to get you guys now to collaborate, because it's important in the work environment, because you may have to work with other data analysts, you may be working with data scientists, data engineers in one project. So now to ask questions, if there are things you can't handle on your own, please. And also knowing how to help other people, something that will serve you well, like really serve you well. So these are soft skills. So feel free to communicate with each other about your project. I will drop the 2 projects tomorrow. They're not difficult per se. No, they're not difficult. They're not difficult. But if there's anything you don't understand, you can review the video or the SQL courses. And since I didn't know the last recording wasn't that good, so I'm going to do is also give you the link to the playlist of the last set, like I said before, so you can, view it. And thank you very much for your time. It's 11 o'clock, almost 11. Let me not delay any longer. So good night. Enjoy.
Good
Adios.
night. I'm be lenient with the questions for tomorrow.
It's a preset question. It's like I've said today, it's preset already.
All right. Good night, then. Do have a lovely night rest. And everyone.
All right. Bye.
Good night, sir. Bye. Good night.
Nina, good night.